I have imported a pcap file into Wireshark, but before digging into deep, we'll see what is TCP. Well, TCP is a protocol which is in the transport layer of OSI model. It is actually the fourth layer. So what transport layer does is, it breaks data received from the session layer into small data units called segments. So a segment has a sequence number, a source port, and the destination port. So why do we need to have a port number? For an example, we'll say we are browsing internet and at the same time we are sending an email. So we use two different applications, but the data is transmitted over the network and all these data packets are mixed together. So if there is no way to differentiate them, the recipient cannot form the message. So the segment adds the source port number and the destination port number to differentiate the applications. So this helps to direct the data to the correct application. Another function of the transport layer is to manage the flow control. If the router is able to send at a higher speed like 10 Mbps and the access point is only able to receive them at a lower speed like 20 Mbps, then transport layer controls sending data by the router at 10 Mbps, which is the correct speed that the access point can manage. When sending and receiving data, there can be missing segments. So this layer adds the checksum and calculates it at the receiving point to see if there is any error at the transmission. Now TCP is a connection-oriented protocol. What it means is, it establishes the connection and then starts the data transmission. In order to establish the connection, TCP works in a method called three-way handshake. Now this illustrates the TCP three-way handshake. Now we have the client and we have the server. Now the client wants to start a connection with the server. So the client sends a request to the server with the SYN flag. So we'll say the sequence number is X. So the server responded to the client's request with the acknowledgement number X+1. The server also sent a SYN flag saying that server also likes to start the connection with the client. So the sequence number can be Y. So the client responded back to the server with the acknowledgement number Y+1. So there are three connections happen here. So we call it TCP three-way handshake. So the client start the handshake with the SYN flag, then the server sent the acknowledgement and the SYN flag, then the client responded back with the acknowledgement. Now we can see how this happens in Wireshark. Now if we look at Wireshark, I have imported a pcap file into Wireshark. You can see the source address and the destination addresses here. Now if you select this first row, you can see the transmission control protocol. And when you expand it, you can see the source port number as well as the destination port number. And you can see here, it's the TCP segment. So the segment is in the transport layer. So the transmission control protocol is in the transport layer. Now here, in the source address, the source is 10.0.2.15 and the destination is 192.168.1.27 and the protocol is TCP. So the source or the client is sending a SYN flag. It's port 49228 to 80. So the SYN flag is here with the sequence number 0. Now in return, the destination receives it and the destination sends the acknowledgement, that is 192.168.1.27 is sending its acknowledgement to 10.0.2.15. So the port 80 to port 49228. So you can see the acknowledgement as well as the SYN flag, that is the request sent by the server to the client for his request. In return, the source, that is the client, send in the acknowledgement. That is 10.0.2.15 is send in the acknowledgement to 192.168.1.27. So the SYN flag, then the SYN and ACK, then the ACK. And the protocol is TCP. So the TCP three-way handshake is this. If you go to the transmission control protocol, you can see the source port number, the destination port, and you can see the status of the conversation. So the status of it is complete with data. And if you move further below, you can see flags, and when you expand it, here you go. The SYN is set to 1. So the first one is the SYN is set to 1. For the second record, that is SYN and the ACK flags, here the acknowledgement is set to 1 and the SYN is set to 1. For the third record, the acknowledgement should be set to 1. So we go to acknowledgement is set to 1, none of the others. So this is the TCP three-way handshake. Now the TCP three-way handshake is done. Now they start exchanging data. The client is sending data to the server is responding, and server is also sending data, and this keep on going. And at one point, they want to terminate this connection. Now to do this, there are two ways. One is to forcefully terminate the connection. It's rather harsh. And the other one is to terminate the connection politely. We'll go to the illustration again. So we'll see how the TCP connection is terminated in a polite manner. For this illustration, the client is sending the SYN flag to the server. So in return, the server responded with an acknowledgement and also a SYN flag, expecting the response from the client. So the client acknowledges to the server with its acknowledgement flag. So this is how the termination is done in TCP connection in a polite manner. So either party, maybe the client, maybe the server, can start the termination by sending the SYN flag, and in return the recipient sends the acknowledgement and also a SYN flag, and the initiator responded with the acknowledgement. So we'll move into Wireshark to see actually what is happening. For the demo purpose, I have imported the pcap file into Wireshark, and you can see the record number 42, 43 and 44. Now under the 42, you can see the source is 192.168.1.27 and the destination is 10.0.2.15. So the source is sending, 192 is sending a SYN flag to the destination, asking to terminate the connection. So the corresponding sequence number is 4812. And in return, 10.0.2.15 is sending an acknowledgement. So the acknowledgement for the SYN flag, the sequence is 4813. So you can see the sequence is 4812 and the acknowledgement is 4813. And 10.0.2.15 is also sending a SYN flag with the sequence number 868. So the initiator 192.168.1.27 is acknowledging for this SYN flag with the acknowledgement number 869. So this is how the termination in TCP connection is done in a polite manner. So the SYN, ACK and ACK. So the next is the harsh termination. So I have imported a pcap file into Wireshark to demonstrate this. So I was maintaining a SSH connection with the server which has the IP address of 54.255.235.57 and my address is 10.0.2.15. So we were exchanging data. The server was sending the encrypted packet and client was acknowledging, and the client was sending the encrypted packet and the service acknowledging. So we were maintaining this connection, and all of suddenly you can see the IP address were gone. Now what happened was I blocked the port number 22 for SSH at the server side through the firewall. So the client was unable to exchange data with the server. So this is the name of the network card for the server, and this is the name of the network card for the client. So if you move to the second pane and analyze the Ethernet frame, you can see the destination. So here the destination is Realtek and its MAC address is 52.54.00.12.35 and 02. And the source is PCS something, which is the name of the network card, and its MAC address is 02.00.27 DB96 and 6A. So this source network card is asking where is 10.0.2.2 through an ARP request. So in return, this network card, the MAC address says I have it. So it says 10.0.2.2 is at 52.54.00.12.35.02, which is the MAC address of this Realtek network card. At this point, the server sends the reset flag. So the server IP address is 52.255.235.57. It sends the reset flag. So the connection is now over. So this is a kind of harsh termination. You do not send the fin flag, then the fin ACK and the ACK, but instead you terminate it little harshly. It's a one-way termination. So this is how the TCP three-way handshake is done and how the TCP connection is terminated with reset flag and with fin flag. So hope you understand it clearly, and please subscribe to my channel for more videos.